Hey everyone, welcome to The Explainer. Today, we're diving into something totally crucial. How do utilities we all rely on every single day actually quantify their defense against extreme weather? We're going to do a deep dive into water and wastewater resiliency metrics, looking at exactly how we measure our infrastructure's strength in the face of a changing climate. So, let's get right into it.
I want you to ask yourself this right off the bat. Is your local water utility truly ready for the next megastorm? It's a high-stakes, real-world reality, right? When extreme weather hits, it is not just about flooded streets. It's about whether clean drinking water actually keeps flowing from your tap and whether wastewater is safely carried away. The reality of climate change means utilities literally can't just cross their fingers and hope for the best anymore. They have to be structurally prepared for the absolute worst.
And this isn't some abstract, distant concept for the future. It's happening right now. Intense precipitation and rising sea levels are actively threatening our most critical water infrastructure. Think about it. Water supply and wastewater disposal are basically our life support systems. Maintaining their operational continuity is absolutely vital for public health and safety.
Well, the blueprint for figuring this out comes from the SASB standards, which are now under the International Sustainability Standards Board. It's essentially the accounting rulebook that forces water utilities to put a hard, standardized number on their vulnerabilities and their resilience. It pushes us way past vague promises and demands concrete data on exactly how climate change is impacting their distribution and wastewater networks. Here is our roadmap for today. 1. The climate threat to utilities. 2. Tracking 100-year flood capacity. 3. Measuring sanitary sewer overflows. 4. Tracking unplanned service disruptions. And 5. The value of resiliency metrics.
Let's kick things off with Section 1, the climate threat to utilities.
The standard identifies some very specific climate-related dangers that are creating immense uncertainty for our water systems. We're talking about rising sea levels, increasing storm intensity, and severe impacts of drought. Many regions are seeing what used to be a once-in-a-century storm happen every single decade now. And the increasing frequency of that intense precipitation can result in sewage volumes that totally exceed a treatment facility's capacity. When that happens, operational continuity is broken and untreated water can be released right into the environment.
Moving right along to Section 2, tracking 100-year flood capacity.
To actually measure vulnerability, we have to know exactly what infrastructure is sitting right in the danger zone. So, the standard defines a 100-year flood zone as land areas subject to a 1% greater chance of flooding in any given year. You might also hear folks call this the 1% annual chance flood. We are looking at places like coastal floodplains, areas along major rivers, or low-lying regions that are prone to severe ponding. So the crucial point here is how we measure this risk. Utilities are required to report the wastewater treatment capacity that is located physically inside these exact 100-year flood zones, and they have to report it specifically in cubic meters per day. This is honestly a brilliant metric because it exposes physical vulnerability in absolute terms. It tells us exactly how much of their daily treatment power could just get knocked completely offline or overwhelmed during a major predictable flood event.
All right, let's jump into Section 3, measuring sanitary sewer overflows.
Okay, let's establish the massive public health stakes of what happens when a system physically just cannot hold any more water. A sanitary sewer overflow, or SSO, is exactly what it sounds like, and yet it is every bit as unpleasant as you're imagining. It is a spill, release, or diversion of untreated wastewater from a sanitary sewer system. The standard requires utilities to track 3 very specific layers of data here. First, they need the total number of these SSOs. Second, the absolute volume of the spills, again in cubic meters. And third, which is critical, the percentage of that overflow volume that they actually managed to recover.
But, how do you even measure a chaotic, messy spill? Well, if local regulations don't already mandate a specific reporting method, the standard provides approved step-by-step calculation methodologies to figure out that spill volume. Utilities might use a duration and flow rate comparison method, actually analyze upstream lateral connections, or they might rely on continuous flow metering. The ultimate goal here is strict, standardized accountability for literally every drop of overflow.
And what about that recovery percentage we talked about? That's the amount of discharged sewage that was successfully captured and put back into the system.
Again, if not legally mandated otherwise, utilities use specific methods like the measured volume method or a structured visual estimation method to calculate this. This is important because it tells us not just that a failure happened, but how effectively and quickly the utility responded to mitigate the mess.
On to Section 4, tracking unplanned service disruptions.
Let's see how all this builds into the direct, everyday impact on the customer when things fail. We need to clarify what actually counts as a disruption under this standard. We aren't talking about a minor, routine drop in water pressure where you can still wash your dishes fine. We are talking about complete water shutoffs, severe low flow restrictions, boil water advisories, and emergency water main flushing. And crucially, the key word here is unplanned, meaning these events were not scheduled with at least 24 hours of advance notice to the public.
Now, this is really interesting. The standard forces utilities to categorize the severity of these disruptions into very strict duration tiers. They have to break down the tracking based on how long the outage lasts, under 4 hours, between 4 and 12 hours, and 12 hours or more. For the short ones, they track the number of disruptions. For the middle tier, it's customers affected, and for the longest ones, it's both metrics combined. This tracking of unplanned service disruptions categorized by duration is super vital because look, a 3-hour shutoff, that's a frustrating inconvenience, but a 3-day boil water advisory, that's a full-blown systemic crisis.
And finally, Section 5, the value of resiliency metrics.
Let's pivot away from the grim reality of the raw data for a second and look at how this transparency actually drives real physical improvements. Utilities are not just tossing this data into a void. They are required to describe their forward-looking efforts to manage these exact vulnerabilities. They use this data to inform major climate change adaptation programs. They deploy advanced current storm tracking and run complex global gridded climate models to predict future stress on the system. And most importantly, they use these insights to build in redundant systems. We're talking backups upon backups to ensure service continuity no matter what the weather decides to do. And I think this brilliantly illustrates the entire purpose of this standard. It takes the undeniable risks, those physical threats to infrastructure and severe service disruptions, and juxtaposes them with a massive opportunity. By forcing utilities to expose these vulnerabilities in plain numbers, it drives essential infrastructure improvements right within current service areas, and it creates amazing opportunities to modernize and expand capabilities. It basically turns a terrified reactive stance into proactive resilience. Which leaves us with this final thought to chew on. As extreme weather accelerates all over the globe, is your local utility actually tracking the right metrics to ensure our future water security? Because as we've seen today, you absolutely cannot manage what you do not measure. Thank you so much for joining me on this deep dive into water utility resiliency. Keep asking those tough questions about your own local infrastructure and keep learning.